Army presents The Big Picture, an official report produced for the armed forces and the American people.
This is the story of Camp Century, the city under ice. It was in May 1959, after more than a year of preparation, that a small party of Army engineers conducted the final search to select a site for Camp Century. Listen now to the voice of Captain Tom Evans, the young officer who was in charge of the construction of the camp.
This was the day we really got underway. Colonel Kirkering, commanding officer of the United States Army Polar Research and Development Center, was with me when we made the final reconnaissance. We needed a flat surface, a level with less than 1 degree of slope. This would minimize construction problems by enabling us to keep all of our tunnels on the same level. We finally picked this plateau, a smooth white plain of ice for as far as you could see. This was the closest location to Thule, our supply base, which would not be affected by the summer thaw. That first day, we set out flags marking the boundaries of the camp. This is rugged country. Nothing lived on the ice cap. Not even seal or caribou survived in this climate. Our job was to cross 150 miles of ice, much of it split by crevasses, and then build a city under the ice, experimenting with new concepts of polar construction. It was several weeks later, at a point where the ice cap sloped down to a narrow strip of barren land along the coast, that our supplies began rolling in by truck for transfer to sleds. To make this transfer possible, we'd had to build a 3-mile road up onto the edge of the ice cap. We brought in everything this way: construction materials, steel arches, clothing, nails, steel beams, prefabricated houses, lumber, food, even ice cream. In the months it took to build Camp Century, more than 6,000 tons of supplies were used. Even the vehicles we used at the site had to be transported over the ice on big bobsleds. We called these convoys of 10 and 20-ton sleds heavy swings. Crawling up the ice cap at approximately 2 miles an hour, a heavy swing would reach the camp in about 70 hours if everything went well. We used wooden caboose-like trailers, wanigans, to house members of the construction crews for the 3-day trip. Mukluk, a 3-month-old Eskimo sled dog, went along as camp mascot, strictly against regulations. Caterpillar tractors with extra-wide treads pulled the heavy swings. Each tractor could pull from 50 to 100 tons. Finally, like a wagon train in the Old West, the first heavy swing got underway. At the same time, we used another type of smaller vehicle to transport an advance party. These polecats would average 10 miles an hour and make the trip in little more than half a day. A convoy of polecats, each section carrying 6 men, was called a light swing. We also used light aircraft. Throughout the operation, these flights brought in key personnel, special cargoes, and mail. We couldn't forget anything. This wasn't country in which to turn around and go back. A compass was useless this close to the pole. Instead, our convoys followed a series of trail markers. Traveling in a wanigan was a long way from the early tractor trains of the 30s with sourdough biscuits and warmed-up beans. From the days spent loading the heavy swing, the men's faces were already deeply sunburned. During the trip in shifts, half the men rode and half slept. Navy-type bunks were used for sleeping, if you could sleep in the 24-hour sunlight. First to arrive at the surface work camp were the aircraft. A few hours later, the polecats pulled in. For the next several months, this primitive scene of crowded James Way Arctic huts with outdoor latrines was our home. Now the real job began. Altogether, I had 4 other officers and a hand-picked group of 11 non-commissioned officers to help supervise the military construction crew of Camp Century. Plans for the camp had been developed months in advance. The basic concept was simple. A system of 23 trenches would be dug into the ice cap and then covered with steel arches and snow. Branching off the main communication trench would be a series of lateral trenches housing complete research, laboratory, and test facilities, modern living quarters and recreation areas, and a complex of support facilities. Since transporting great quantities of diesel fuel over vast Arctic wastes was impractical, we would install a nuclear power plant. We got to work immediately cutting trenches. This snow milling machine, the Peter plow, was our pride and joy. Manufactured in Switzerland, it could handle up to 1,200 cubic yards of snow an hour. Designed to clear roads in the Alps, it was ideal for our purpose, being capable of making extremely precise cuts. It was usually operated by 2 men, one controlling the machine's horizontal movement, the other controlling its vertical movement and speed. When a trench was several feet deep, planks were put down on the shoulders of the cut. Later on, these planks would be used to support the steel arch roof which would cover the trench. Camp Century was starting to grow, and so was Muckluck. We used 3 Peter plows to cut all the different trenches we needed. By making a series of undercuts, the width of most of the lateral trenches was greater at the bottom than at the top. This cut down on the amount of roofing material required. Before long, the first roofs began to go into place. Constructed of overlapping steel arches, these roofs could be put up very quickly. By this time, we had a crew working in a snow quarry cutting large bricks of snow. In this way, we made maximum use of the materials available at the site. Somehow, Muckluck seemed to be everywhere, always making himself useful. When a roof of steel arches was in place, it was covered with snow. Because it had been milled, this snow would harden into an extremely durable surface. Inside each tunnel, at the end adjoining the main communication tunnel, passages were cut through. Not all the excavation could be done by machine. The shovel was still a very useful tool. Next, work began on foundations for the prefabricated buildings that would be placed within the tunnels. Leveling the floor was very important to provide a good bearing for the foundations and prevent any building from settling unevenly. This was cold work. The temperature within these tunnels sometimes went to 20 degrees below zero, and this was summer. Prefabricated sections were delivered by forklift. The non-conductive wood and the air insulation barrier below it protected both the building from the cold of the ice floor and the ice floor from the warmth of the building. Every prefab that went into Camp Century had been pre-erected, tested, and then shipped to us as a unit. Every clip, every doorknob, every light switch came in a single shipment. In this way, we knew there would be no delays caused by missing parts. This is a standard T5 Engineer Arctic building, designed for cold weather use. Composed of plywood insulation panels, these buildings would provide space for comfortable working and living under the ice. Since every unit had been checked out in advance, our crews could put up one of these buildings in less than a day. As soon as the shell was completed, crews began to wire the buildings for interim power provided by diesel generators. As the major interior work within each tunnel was completed, the entranceway was blocked up with bricks of snow. It took about 2 days to build one of these walls. Once in place, these bricks would bond together into a solid wall, and only a small entranceway would be left. We then used a bulldozer to push loose snow into the doorway of the tunnel to complete the seal. Later, an escape hatch would be placed at the end of a small wooden form for an emergency exit. When it was completed, the entrance was weatherproof and serviceable. Throughout the long period of construction, within the primitive facilities of the work camp, the men solved the everyday problems of working and living as best they could. Meanwhile, work had begun on the 4 nuclear trenches. These were the widest and deepest trenches and did not use the undercutting principle. On this cut, we used 3 plows simultaneously, 2 plows throwing up snow from below, the third cutting a spoil trench up above to prevent loose snow from sliding back into the cut. To avoid melting caused by the sun, much of this work was done at night. These scenes were filmed at 2 a.m. Until the trench was covered, there was always a threat that the 40-foot arches would collapse a shoulder already weakened by the 24-hour-a-day Arctic sunlight. The faster the roof went up, the better. The frame for the reactor building was made of steel beams. Despite the cold and the constant winds, my construction workers climbed like monkeys over the scaffolding and rode the beams into place. At the same time, within the tunnels already completed, we were installing piping for water and electricity. Heavy insulation material was wrapped around every pipe to protect against the extreme cold. A copper heating element inside the insulation kept water lines from freezing. Flexible sewage lines also had to be run through the camp. At this time, to keep on schedule, we were using 12 and sometimes 14-hour shifts. For like any modern city, Camp Century required a complex of interconnecting corridors carrying a maze of piping of all sizes and shapes. One of our proudest achievements was our solution of the water problem. A steam hose with a special drilling nozzle was used to melt a hole 3.5 feet in diameter, 120 feet down into the ice cap, until a pool of water formed which did not drain off. This pool provided 10,000 gallons of fresh water daily. Throughout the camp, an extensive electrical system was now installed. For electrical heating would not only be clean, but it would also reduce the threat of fire. And fire was the worst hazard under the ice. From the very beginning, we had to take precautions against fire, or a storm closing the ramps, or any other disaster which might block the regular entrances to the camp. 16 of these escape hatches were strategically located throughout the various tunnels. In their off-duty hours, the men did what they could to amuse themselves with the recreational opportunities at hand. Bronco busting was one favorite pastime. By this time, muckluck was almost full grown. By early July, most of the heavy construction work on the tunnels was completed. Throughout this operation, it was a steady stream of heavy swings moving back and forth across the ice, more than any other single factor that made it possible for us to complete Camp Century on schedule. To service our many vehicles, a maintenance shop was constructed closer to the surface, both as a repair shop and as a garage. For the sub-zero temperatures meant equipment had to be kept warm. Otherwise, engines wouldn't start, lubricating oil solidified, and electrical connections froze. It was at this time that the Marine Fiddler arrived at Thule with the nuclear power plant. Designed for air transportability but transported by sea to reduce costs, the nuclear plant was the last major phase of our operation and the most difficult. This unit, for example, part of a vapor container, weighed more than 21 tons. Awkward to handle and with high centers of gravity, these packages were delivered to the ice cap over a road built specifically for their transport. More than 400 tons of piping and machinery arrived in this one shipment. Since the Arctic cold makes metal very brittle, each unit had to be handled with great care. The vapor container, the largest single item in the power plant, was carried on a special flat-bottom sled built expressly for its transport. Everything seemed fine the morning the heavy swing moved out. But unfortunately, it was only a few hours later that one of the worst storms of the season blew up. To complete preparations to receive the nuclear plant, my crews bundled up and kept on working. The opening in the roof of the main nuclear trench now had to be closed quickly before the trench began filling with snow. Despite the storm, the heavy swing was still moving. At our end, my crews kept working. It was the only way we could be ready. Just as the swing arrived at the camp, the storm let up entirely. Work began immediately unloading the shipment in preparation for its emplacement. Covers were removed, crates opened. Boxes of piping and wiring, each item carefully labeled, were opened so that each unit would be available when needed. Major components shipped in pieces because of weight limitations were reassembled before being moved into the trenches. The condenser, 15 tons of steel, was one of the first units to be moved into the tunnel, prepared to house it. When the condenser was slowly winched forward, small tracked rollers supported its entire weight. Next, still mounted on its special sled, the vapor container was eased down the ramp by 3 tractors, one in front pulling and 2 in back to keep it from slipping. To bear the weight of the vapor container, the reactor building was constructed around a framework of steel beams. The floor was of heavy planking mounted on other steel beams. We had to use hand rigging methods, the best we could do under the confined conditions, to put the nuclear equipment in place. The power plant consisted of 4 basic elements: a nuclear heat source, equipment that would convert the heat energy into electrical energy, and a system to dispose of excess heat, all regulated by an extensive network of instruments and controls. The last buildings to be assembled were those that would contain the nuclear sections. These shells were built around the nuclear system equipment only after every major component had been put in place. The next phase was to be the activation of the nuclear power plant. Wearing the white safety hat is Captain Jim Barnett,